Hello, it's GCSE Physics Explained. I'm going to take you through a physics triple paper. You can tell it's the triple paper because it's got the code PH and it's on for 1 hour and 45 minutes. This is from Wednesday the 22nd of May 2019 and it's the higher tier paper 1. The work done to bring a car to rest is given by the equation. Work done equals braking force times by braking distance. Which of these graphs is correct for the car if a constant braking force is applied? So they've got work done up the side and braking distance along the bottom in each case. So braking force, constant braking force. So if we rearrange this equation, now if we need the force to be constant, that would mean that if the work was to double, the distance would also have to double. If the work was to triple, then the distance would have to triple. In other words, the relationship is proportional. Now you recognise a proportional relationship on a graph by it being a straight line going up from bottom left to top right. So the only graph that can be correct is this graph here, graph A. Part B. Before the car brakes, it has kinetic energy. The kinetic energy decreases as it brakes. State what happens to the kinetic energy during braking. It's always the same. It gets converted into heat and it's transferred to the surroundings. If it was worth 2 marks, you often get 1 mark for saying what's happened to it and 1 mark for saying where it's went. Question C. The graph in figure 1 shows how the braking distance d of a car depends on the velocity v of the car when the brakes are first applied. An equation relating distance, braking distance d to velocity v is d equals v squared over c, where c is a constant. Use the equation and data from the graph in figure 1 to calculate a value for c and give a unit for c. So these questions often come up. We need to rearrange this equation to make c our target. And we've got to prove that c is a constant. So if we take a few values from the graph and see if c comes out as the same each time. In terms of the units for c, you've got velocity, which is being squared, and you've got that being divided by the distance. So if you square the velocity, well, velocity is in meters per second. And we're dividing that by distance, which is in meters. Now we need to square the top, so that would be meters squared, seconds squared. Now that meters is going to cancel out with that squared, and that's just going to leave meters per second squared. Now if we pick some values, well, that looks like a nice convenient value. So you can see that d is 32 and v is 20. So if we pop that in, that equals 12.5. Prove that these are a constant. If that was the case, then if we were to pick some other values, so we can see that d is 8 and v is 10. So if we were to pop those in, that also comes out as 12.5. We've also proven that C is a constant. I don't think this particular question asked for that, but just in case it did, that's how you do that. Question 2a. Which colour of visible light has the longest wavelength? Well, I guess that's either something you know or you don't know, but the answer is red. If you consider the electromagnetic spectrum, red is longer and the wavelength gets shorter and shorter and shorter as you go towards violet. Richard of York gave battle in vain. So red is where the wavelengths are the longest. If it did ask which one's got the shortest, that would be violet. 2b. Some television remote controls use infrared radiation and other remote controls use radio waves. Explain why an infrared remote control may not switch on the television from behind an armchair, but a radio remote control always will. Well, radio waves have got a longer wavelength, which means they diffract more. So it'll diffract round the armchair more than what the infrared would. So if that's the TV, and that's the armchair, radio waves would diffract more, which means spread out. Infrared waves are closer together. The wavelength is much shorter, so they don't diffract as much. Question C. Figure 2 is a diagram of a water wave. A cork is floating on the water. Use the scale on the diagram to measure the wavelength of the wave. So the wavelength is just the length of the wave. So we can see that the wave is starting here at a distance of 0, and a complete wavelength goes all the way up, back down the middle, all the way down and back down to the middle. So that length there is 12 centimeters. Describe the motion of the cork. You should include how the cork moves relative to the direction of travel of the wave. So the wave is travelling this way and the cork is moving up and down. Now that's what you call a transverse wave, where the vibrations are at right angles to the direction that the wave is travelling. And that's, like I say, that's a transverse wave. I'd expect 1 mark for that, 1 mark for that, and even maybe 1 mark for that if it was worth 3. So I've definitely got the 2 marks. Question D. A different water wave has a wavelength of 0.25 meters and a frequency of 1.5 hertz. Calculate the wave speed. So wave speed is frequency times by wavelength. So the frequency is 1.5 hertz. The wavelength is 0.25 meters. And you multiply that together, and that's 0.375. Now, the greatest number of decimal places that they have used is 2 decimal places, so we'll just round that up to 0.38. And that's a question that I get asked quite often. How many decimal places should I use? And my answer is always the same. Use the most amount of decimal places that they did when they presented the information to you. So that is presented as 2 decimal places. That's presented as 1. So we'll go 2, the same as this one. Question 3. Carbon-13 and carbon-14 are isotopes of carbon. Nuclei of carbon-13 and carbon-14 can be represented by these symbols. So 13,6, 14,6. Complete the table for an atom of carbon-13 and an atom of carbon-14. Number of neutrons in the nucleus. So what they're looking for is that you understand A represents the mass number, which is the number of protons added to the number of neutrons, and Z represents the number of protons, the proton number, or what we call the atomic number. So the number of neutrons in a nucleus, we get that by doing A take away Z. Remember, Z is the number of protons, and A is the number of protons added to the number of neutrons. So if we take the number of protons away from the number of protons and neutrons, we just get the number of neutrons. So A take away Z for carbon-13, 13 take away 6, which is 7. And if we do A take away Z for carbon-14, that's 14 take away 6, which is 8. The number of electrons in orbit around the nucleus. Well, all atoms are electrically neutral. Now, protons have got a positive charge and electrons have got a negative charge. So an atom always has the same number of protons and electrons. So if we look at the proton number, that also tells us how many electrons there are. So carbon-13 must have 6 electrons, and carbon-14 also has 6 electrons. So normally they would ask how many protons they've got, so they've just tried to catch you out and try to be a little bit clever there. That's fine. And just to make sure that you understand what an isotope is, it's something that's got the same number of protons but a different number of neutrons. That's why that top number is different, because that's the number of neutrons and protons added together. State the name of an instrument that can be used to measure radioactivity. That's a Geiger-Müller tube or a Geiger counter. Sometimes just referred to as a GM tube. State 2 sources of background radiation. I've got a nice video to do with that on my channel if you want to click the link above. Background radiation comes from rocks, food, comes from cosmic rays from space, comes from hospitals, nuclear power stations, lots of different places. Part C. Carbon-14 is radioactive and has a half-life of 5,700 years. The number of radioactive carbon-14 atoms in a very old piece of wood is found to have decreased from 1 million down to 125,000. Determine the age of the piece of wood. So you've got to understand what a half-life is. So a half-life is the amount of time that it takes for the amount of radiation to half. Now you could either say radiation in terms of activity or in terms of how many radioactive nuclei you've got. So if we're going, I always set it out the same. We're going from 1,000,000. So if we halved it once, that would go down to 500,000. Then if we halved it again, that would go down to 250,000. And then we need to halve it again to get it down to 125,000. So what we've got then is 1, 2, 3 half-lives. Now it's said up here that a half-life is 5,700 years. So 3 half-lives. And that equals 17,100 years. Question D. Carbon-14 decays into nitrogen-14. The symbol for nitrogen-14 is 14,7N. Explain what happens in a carbon-14 nucleus when it decays to a nitrogen-14 nucleus. Okay, so we are going to start with a carbon-14 nucleus, and it tells us that carbon-14 is over here. So the 14 is referring to its mass number. So we've got this, and it's going to decay, and we know that it's going to turn into nitrogen, which is 14,7. Now, we're also going to get something else produced. Now, this is a question in itself sometimes, finding out what this thing here is. Now, the rules when you're balancing these nuclear equations are these numbers on the top, on the right of the arrow, have to equal the numbers on the top on the left of the arrow. I've got a lovely video that shows you all about radioactive decay. Click the link at the top of the video. So 14 plus something has to equal 14. Well, that something has to be 0. And these numbers on the bottom, on the right of the arrow, have to equal the number on the bottom on the left of the arrow. So we need to make 6. So 7 plus something equals 6. Well, this must be minus 1. Now there's 3 types of radioactive decay. You've got alpha, which has got a... That's the police coming for us. Just kidding. You've got alpha, which has got a mass of 4 and a charge of 2. You've got beta, which is basically a fast-moving electron, which has got a mass of 0 and a charge of minus 1. And you've got gamma, which has got a mass of 0 and a charge of 0. So 0 minus 1, that is a beta particle. Now, how do you get a beta particle? Well, one of the neutrons from inside here. Now a neutron, it's got a mass of 1, but it's neutral. It's got a charge of 0, and that turns into a proton, which has got a mass of 1 and a charge of 1. So I'll just put the plus 1 there, just to make it easy. You'll see why in a second. Now we must get something else. Now, what do we add to 1 to equal 1? We add 0. And what do we add to plus 1 to make 0? We add minus 1. So that little electron, that beta particle, that's how we get the beta particle formed. A neutron splits up into a proton and a beta particle. And that's what we need to tell the examiner. Electrons normally orbit around the outside of an atom, but this is when an electron comes from the nucleus of the atom when there's radioactive decay. Again, it's all explained on my radioactive decay video. So that's what you'd have to put for the 2 marks, but I've gave you a lot more information there, hopefully to help you. And make sure you understand these 3 symbols for alpha, beta and gamma. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Thanks very much and bye for now.